So in the last unit, when we had a problem like this, we would say, make the bases the same. Well, you can't. We can't make the bases the same on this kind. Like when it was like 2 to the x equals 8, that was doable because you could make the 8 into 2 to the third. You remember this deal? And you set the powers equal. But what if you can't? What if you can't make them the same base? That's what logs are for. All right, so for right now, I'm just going to show you how a log could be done, but I don't want you to get your calculators out right now, okay? Because a calculator could theoretically do a log, but the thing is, you can't use calculators on your next test. So it's not going to be about just hitting like log of 5 equals 8 and log base 5 of 8. It's not going to be like that. So I'm going to say, I'll just be your calculator. If I wanted to write the log for this, I would say log. Everybody write this. This goes together. I'm not saying they're equal. That's why I'm using the double arrow thing like this. This goes with log base. Which of these looks like the base to you? The 5 or the 8? Which one feels like it's a base? The 5. That is the base. Log base 5 of 8. Next thing is, kids don't know how to say this, which I understand. They just read it as log 5, 8. Nope. You got to say log, and you have to say the word base for this one. And you have to say of before that one to want to look like you know what you're talking about. Log base 5 of 8. Log base 5 of 8. That's how you say a log. Now, actually, what is the answer? Well, I'm going to make you think about it in your head. Would you agree that 2 would be too big? I want you to think that through. Log is going to tell us the exact answer, but 2 would have been way too big. Log, if I put an x is 2 there, then it's 25, not 8. Would you agree that 1 would be too small? So do you get it's an answer between 1 and 2? Got to be 1 point something. That's where the log can calculate it exactly, and that's where usually you'd have a calculator do it. What did they do before calculators? They actually needed logs before there was calculators. And so there was 2 ways to do it. They had big charts made up where you could look it up in a book and like flip to the right decimal and then you could look it up in a chart. And they had this cool, it's really an amazing tool called a slide rule. It was made of plastic, and all the engineers, my dad was an engineer, they all knew how to use their slide rule. They grabbed the slide rule and slide this thing, and it was basically a mechanical calculator that can give you this decimal. All right, so we don't have any way unless you have one of those slide rules, or unless you have a chart for you to look this up, other than to say that the answer must be between 1 and 2. That's good enough for now. And that the answer is log base 5 of 8. All right, now let's see if you really caught that. What if I change the problem to 25 to the what is 26? Well, 1, would you agree the answer is pretty close to 1? Is it bigger than 1? Is 2 probably way too big? So would you agree it's like 1.1 or 1.2, something pretty small above 1? Okay, so then you're getting estimates of logs, and that's good enough for now. Okay, but what is the log answer to this? This is called an exponential because it has an x in the exponent. If you understood how I just made that last log, you should be able to make me a log for this. What is it? Log base what of what? What is it? Log base 25. Log base 25 of 26. And that's your answer. Well, can you go backwards? What if I give you the log? Like, what if I give you this? Can you go and make me that? I bet you probably can. If I said log base 3 of 5, try to write that as an exponential. Again, I'm not going to say equals because they're not the same thing, but I'm going to make an arrow to the log changing over to an exponential. Remember which one the base was? Isn't the base 3? So it's 3 to the x equals 5. Who had that already? Okay, awesome. I think you get the idea. These are like exponentials. That's why we taught you exponentials first. And now we're teaching you logs because they're very similar to each other. So if you have a log, you can rewrite it as an exponential. And can I do this in my head? Nobody can do it perfectly. But could you estimate it? Would you agree 3 to the 1 is too small? 3 to the 2 is too big. Would you agree it's between 1 and 2? What do you think it's closer to? 1 or 2? Well, I'm going to write one above it and one below it. 3 to the 1 was 3, and 3 to the 2 was 9. Is 5 closer to 3 or closer to 9? 3. So therefore, it must be closer to 1. So it's probably like, it's not 1, it's not 2, it's probably kind of in between. What would exactly in between be? 1.5. So our answer is probably a little closer to the 1. So then maybe 1.4 or 1.3. Raise your hand if you knew what I was talking about there. Okay, good. All right, so that's estimating logs, which is one part of your assignment. And then it's also writing logs as exponentials and exponentials as logs. All right, so what if I do it only with letters? Log base m of p. Can you make that into an exponential? That's usually a thing we do in pre-calc a lot, where we get all the numbers out of there and we just replace them with variables and see if the kid can still handle it. Did you say m to the x power equals p? All right, good. Next thing I got to teach you about logs is what the basis can and can't be. It's not just like anything goes. Like this does not exist. You can't have bases that are negative. You can't have, oh, what's this spot called? Well, this one we figured out is called the base. That's not called the of. You just say it with an of. That spot is called the argument. This spot's called the base. And the other spot is called the argument. Can you put your phone in your backpack? That's very distracting. It's like Siri decided to burn you today. All right. So, what are the rules on the base? I'm going to put them underneath here. It can't be 0. You're not allowed to be a 0 base either. It has to be a positive number. And it's not quite as simple as from 0 to infinity. It's not that simple, but it's almost that simple. The only base that's positive that doesn't work is 1. You can't have a base of 1. I'll explain why in a minute, but for right now, I'm just going to describe this in words because the other 8 way is going to look really complicated. It's going to be positive, but not 1. I'll show you why in just a sec, but your bases have to be positive numbers. They can't be 0, and they can't be 1. Yes?
So decimals between 0 and 1?
Yep, you can have fraction bases. That's okay, as long as they're not 1. Okay, so could you have a base of 7? Yes. Could you have a base of 1? No. Could you have a base of 1/3?
Sure.
Yes. It's positive and it's not 1. That's the rules. 1/3 is positive and 1/3 is not a 1, so that's the rules for the base. How about the argument? That's simpler. It just has to be, well, it has to be positive, period. That means it can't be 0, but just has to be positive. The arguments have to be positive. All right, let me show you that one about why the base can't be 1. I'm going to give you an example. Log base 1 of 5 is equal to, well, I don't know. I don't know what it equals, so I'm going to put an x there. I could put an n there. Maybe that would make you like that better than an x, because you're going to be like, isn't the x supposed to be in the exponent? Let's just call it n. I don't know what this is, so I'm going to call it n. Are you with me so far? If log base 1 could exist, it'd be like this, and this would be 1 as the base to the power of n is equal to 5. That's the appropriate exponential. 1 to the x has to equal 5. Now tell me, 1 to the what? There's no way to do it. That's why you can't have a base of 1. Because there's no way to make that work. There's no power ever that can make this equal 5. Okay, so that's why the base can't be 1. It's just no solution. The end. Simple question. They just made something impossible. It's kind of like saying, I think the answer is 1 over 0. That doesn't exist. There is no answer like that. No solution. Technically, we say undefined for that. So would this be undefined? Okay, so you can't have a base of 1. All right, so let's do a couple more normal logs. Log base 3 of 3 squared. Well, 3 squared is just 9. Why didn't you put 9? I'm going to show you why in a second. Log base 3 of 3 squared. I don't know what this equals, so I can always put an n there. Now would you rewrite this as exponential? You know, the log will be gone. It's 3 for the base to the power of n, and I call this the circle of logs. It's a little bit like the circle of life. 3 to this power has to equal all of that. 3 to the n equals 3 squared. Ooh, it's one of those deals where I have the base the same. What's n got to be? 2. Do you see why I wrote the 3 squared instead of the 9? Because now I'm about to start telling you a whole bunch of facts about logs that'll make your life easier. If the base of the log and the base that has a power on it, you know, look, this is the argument. Would you agree that that 3 is also kind of a base? It's a base because it's got a 2 on it. They're both bases in a different way. If those bases are the same, then the answer is already there. It's the exponent. N was 2. You can see it right here, but I can tell that that has to be 2. Because 3 squared would equal 3 squared. So now you should be able to go log base 5 of 5 squared. What's the answer? 2. Done. Because if the bases are the same, the answer is that power. If that's blowing your mind, it's just take a second and just think. If I said it equal to n, wouldn't then 5 to the n have to equal 5 squared? And so n has to be the 2? Does that make sense? All right. So then what if I said log base 5 of 25? What's the answer? 2. Because this is really 5 squared, and then the base is the same, and the answer is the exponent. So it's 2. I think you're catching on to some of the simple logs. One of my favorite, you remember how I just told you the rules about logs? So what's this answer? No solution or undefined. Very good. Why? Because you can't have a base of 1. It's just illegal. So they used to say no solution. One of my favorite little sayings, a kid asked me to write a letter for him for a scholarship he was applying for. And he repeated this back to me. He was like, one of the things he remembered of my class was this. Actually, no, this was different. This is an email from a kid who's in med school right now. And he said, I remembered something about your class, and I wanted to just email him because he was trying to explain to a friend about why this answer was equal to what it's equal to, which I'll tell you in a second. And he said, I remembered the thing you said. Because I say, if you won the argument, you get nothing. And it's true in life too. You and your friend, I got a good friend who is on the opposite side of the politics scale as me. And so if we argue about that, do you think I'm going to change his mind?
Oh,
Do you think he's going to change my mind?
nope.
No. Can we discuss things? Sure, we can talk about things, but if we argue about it, you get nothing. You get nothing out of it. Even if you won the argument, you can get nothing. Like I sometimes will do that with my wife. I'll have a better argument than her, and all of a sudden I'm like, see, I'm right, and then I get nothing out of that. She just gets angry because like she can't figure out a good way to counter argue, but she still thinks she's right. My point, if there's a 1 right there, you could win, be a 1 in the argument, that's the argument spot, and you will always get nothing. Why? Because 3 to the 0 is 1, the circle of logs again. Okay, so if you ever see a 1 right here, super simple answer. Got a 1 in the argument, boom, the whole thing's equal to 0. Okay. That's 2 of your properties. So far what we've done is things like this. If I said this is 4 and this is 16, you're supposed to be able to go, oh, so 4 squared, so the answer's 2, right? And then what if I put a 1 right here? What's the answer? 0, because there's a 1 in the argument spot. What if there's a 1 right down there? Undefined. Can't do that. Can't have a base of 1. What if it's log base 7 of negative 25? Can't do that. No solution. Not allowed. What if it's not negative 25? What if it's just 25? Then all you could do is rewrite it as an exponential. Please do that. I'm reviewing right now. Reviewing everything I've taught you about logs. You can't solve this, but you can write it as an exponential. Try it, Jack. Write it as an exponential. And then there better be an x in the exponent or you're doing it wrong. Compare with the kid next to you. Okay, here's what you should have been thinking. I don't know what it equals, so I'm going to put an n over there. So it's 7 to the n equals 25. Is this one you could do in your head? No, but you could estimate it. Would you agree 1 is too small? Would you agree that 2 is too big? Then give your best estimate on n. Not just that it's between 1 and 2, that'd be a little too easy. 1 point what? 7 to the 1 is 7. 7 to the 2 is 49. What's it closer to? 1.5 would be exactly in between. Is this exactly in between? No, it's it's a little closer to 1, so it's like 1.4. Raise your hand if you were in the neighborhood of 1.4-ish, maybe 1.3. Okay, good. Okay, I still have more to teach you. And that's when you add logs together. You can add them together if they have the same base, but it's weird. Would you agree these have the same base? Then it's kind of like they're like terms, and so you can put them together into one log. And you know my favorite saying, if you can factor it, you should, up here? Well, in logs, is if you can make them into one base, like one log, you should. So if you can make these into one log, you should. So you make them into log base 3 of, and anybody want to guess what the 5 and the 4 do? Just take a guess.
Add.
Add would be the most logical choice, but that's not right.
Times.
Times is correct. If the bases are the same, then they can go together because they're like terms. All right, now let's stretch you a little bit. I'm going to make this same problem, except let's change the 5 to an x. Just put an x right there. And I know you're like, I don't want the x to be there, but that's where it is. They said that's x. That could be any letter. It could be a P, could be a Q, could be an A, any letter. Now can you put them together? Sure you can. But wait, the rest of the problem would look like this. Equals log base 3 of 24. All right, what did I say about if you had 2 logs, you should what? Combine them. Go ahead, combine them and rewrite this problem, and I think you're going to be like, oh, I get it. Combine these into one log. If you can combine them, combine them. I know you know it's log base 3, and I think you know it's 4x, but just write it and you'll see. Log base 3 of 24. Do you get it? I know the answer. Do you know the answer? What's x? X has to be 6. Do you get how log base 3 of 4x equals log base 3 of 24 means that the 4x must be like the 24 and then the x must be 6. I am not canceling these off, but it's kind of like that. Do you get that? Now I can just say I'm not canceling them, but I could say that 4x will be equal to 24. So therefore x must be 6. All right, let's do another one like that. Log base 4 of x plus log base 4 of 7 equals log base 4 of 21. Did you have log base 4 of 7x? I know it's x7, but you should really reverse them and say 7x. And as soon as you look at this, you're going to be like, oh, it's obvious. That must equal that. And I wrote 27, I meant 21. And therefore, x must be 3. Raise your hand if you had x is 3. Okay, awesome. All right, cool. This is just scratching the surface of logs. But what we just did is actually 2 days of logs. If that felt like a lot, it's because we got behind 1 day last week, and we just caught up. That was 2 days worth of logs. So that was a lot, I know. And why did we get behind last week? Because I took an extra day of review, because I think a lot of people would have had a bad day. Right before conferences, it would have been a bad time to bond that test. Took an extra day of review. Most people got A's. Yay, I feel like it worked. And now we're kind of caught up. Again, if you feel a little lost on today's, it's because we just did 2 days. And after a couple days, you'll be all caught up and it'll feel better. So let's start the homework together, though. Everybody, find the homework. And you actually have a fair amount of time to work on it. And I'm going to cut a few out, of course, as I always do. And then I'm going to hand your test back where you can do corrections if you want to. Thank you. Let me look at this one. Could you read me 1A?
Log 2, 20. Log 2 of 20.
Log base 2 of 20, yes?
I and then blank.
And that's where it's basically asking me to try to tell what it's between. So it's between log base 2 of 20. They're trying to say it's between what and what. Remember we talked about these where you could put it to a power? What I would do is just go, that's like 2 to some power is 20. Is 2 to the first going to work? No. Is 2 to the second going to work? No, but still too small. Is 2 to the third going to work? Still too small. Is 2 to the fourth going to work? 2 to the fourth is 16. That's close to 20. So it's between 4 and is 2 to the fifth too big? So it's between 4 and 5. Do you get that? If I were you, the first thing I would do is write this 2 to the x equals 20 thing, and then start putting in numbers in your head until you find, oh, it's between this and this. Part B. Would you read me part B, please?
Log base 3 of 1.
So they're just asking, is what's it between? So what do you think? Well, I'd go like this. 3 to the x equals 20. Is 1 too small? Yeah, it's way too small. Is 2? 2 is 9. What would 3 make? That's too big. So it's between 2 and 3. Getting this? Okay. So finish 1, A, B, C. How many parts are there? A, B, C, D? All right, just those 3, I guess. Oh, wait. And then there's a part I, and... Oh, that's just where you're supposed to rewrite it. So, like, over onto the side, over here, is where you're supposed to write it. Like this part goes over here.
So you have to use a calculator for that.
Oh, we're not going to do the calculator part.
Can we just cross it off?
I agree. I thought that's what they wanted me to do is write that over there, but if it's asking for the decimal, we're not using calculators. I think that just kind of clouds the issue. Kids think they can solve them all by using the calculator, and you definitely cannot. Okay, Carter, read me problem 2. Part A. If there is a part A.
Log base 3 of 3, and then there's a 5.
To the 5th.
To the 5th?
Yeah.
Do you know what the answer is?
No.
If the bases are the same, the answer's already there. It's just 5. A reminder, if these two are the same,
Bases are the same.
this part, the power, is the answer. And he's doing the same thing I want to do, which is like, because if there was an n over here, it'd be 3 to the something equals 3 to the 5th. And so then the answer must be that power. It must be 5. 3 to the 5th would equal 3 to the 5th. This must be a 5. So n is 5. How is it structured, Keenan? Is it like 2a, 2b, 2c?
Yeah.
What's b?
B is 5 times, it's like 5 log, this is base 5 of 2.
All right. Whenever it's like that, what do they want? Do they want they don't want the decimal answer, do they? Because all you'd have to do is type in 5 times log base 5 of 2. What?
They want X.
Is there an x?
Yeah,
Should-
technically.
Oh,
So
equals x.
No.
No? Okay, I gotta see.
No.
I see. I see the problem. Okay.
They want you to find that.
So, would you agree that if there isn't any variable, I could say equals x? Would you agree with that? Good. Then, let's rewrite this puppy. But I think I need to tell you about another little trick of logs that I haven't told you yet. So let me tell you this part. This is going to be weird. Pay attention, gentlemen. Listen, this is really important. Something I haven't told you that's huge. That 5 can move up and be a power on the argument. Why? I'll explain it in a minute, but for right now, do you see that now I could rewrite this better as 5 to the x equals 2 to the 5th. Pause for a second. This is just in my opinion, a bad question, because without a calculator, You're stuck with not being able to solve this thing and evaluating it. We are good enough. Just leaving it in either form, either this way or this way, is all you can do without a calculator. That is good enough. Just leave it like that. Okay, would you read me 2C, please, Keenan?
Log base 8
Log base 8
of 1.
of 1. Ooh, I know that answer.
0.
0. Won the argument. You get nothing. Done. How about D, Keenan?
Log base 6 of 3 plus log base 6 of 12.
Ah, I know how to do this kind. You remember how to do this kind? The bases are the same, so you can combine them. So what do you think?
Well, don't you multiply the arguments?
So make it into one log.
Log base 6,
Base 6
36.
of 36. And ooh, I know another thing about that.
6 squared equals 6.
So then if this is really log base 6 of 6 squared, the answer simplifies to just 2 because the bases are the same. So the answer is already there. You have a question?
For the one that said you couldn't solve,
I didn't say you couldn't solve it. I just said that I think that it's a bad question.
I thought that when it multiplies, you put it to the 5, so it can be like, well,
You could write it as 2 separate logs.
yeah, then logs equal the logs, and then log base 5 to the x equals log base 5 to the second.
Okay, so we can do that.
2.
I can do that. Hold on just a second. So you want to say, now is this is 2 to the 5th though, not 2 times 5.
Yeah.
Okay, so what do you want to write this as?
Well, I did log base 5 to the x. I let's split it up. I put the 2 logs on both sides, and then put the 5 on the second log.
Okay, so how did you get a log on the other side?
I don't really know, but it solves with the calculator, and I checked the answer key, and it's the same thing.
Okay, so I need to know how we could get a log on the other side to do it the way you just described. But I'm not saying that it doesn't simplify more. It may. But what I'm trying to say is for us right now, this problem is too hard. And you can go ahead and look at the key, and that's cool. But I want to stop working on part B because that's beyond where we are right now. Because we're really on the first day of logs, but this is the day 2 worksheet. So we'll come back to ones like that. Let's move on. Feel free to look at the key if you want to. You want to tell me a different way to do it that brings, go ahead.
When you look at the answer key, it looks like it's saying 5 to the power of log base 5.
Oh, you mean this wasn't a times 5 in the front the whole time? Arrgh.
It looks like it's 5 to the power.
Okay, that's just, I'm going to blame myself for not being more, like I should have looked at the worksheet and not just believed what somebody told me. If that, I know it looks, okay, so now if that's problem, the answer is definitely 2, and let me explain why. Okay, this is a power. And there's another little trick with logs that I haven't taught you. It's called a property of logs, if you're going to be more formal about it. There's a property of logs here that says that if the bases are the same, you remember me saying that? Do you get how this is actually a base that has a power on it? And that's a base of the log. The bases are the same again, then the answer's already there. That's the answer. The answer is just 2. I thought it was 5 times in the front. That totally is a different question. 5 to the power of. All right, so let me just show you one more like that in case you were confused, and I get why you would be. Log base 2, then it wouldn't work because the bases wouldn't be the same. But if this was a log base 7 of like 5, then the answer to that is 5. Why? Because if the bases are the same, the answer's already there, and the answer would be 5. But why? Because if I put n over here, because I don't know what it is, then I can say this is a big exponential. Now, I'm going to show this only for the kids who are like, I want to know why that works. I want to know why the answer's 5. If you're the type who's just like, well, you told me if the bases are the same, the answer's 5. Oh, and if you're good with that, fine. But I'm going to show you if you really want to know. It's because if I think of this as an exponential, then I can rewrite this as a log. And I go, okay, it's a log problem, really, with a base of 7. Log base 7. Again, I know some of you are annoyed with the y. You just want to know how to do it. Well, the answer is 5, but here's why it's 5. Because 7 to the n would have to equal log base 7 of 5 because of the circle of logs. And now, okay, for those that want to understand why that pattern worked, and I know I've lost a bunch of you and I understand this is tricky. This is log base 7 of n is equal to log base 7 of 5. From doing the rewrite, this was the base of n equals log base 7 of 5. All of that was what it equaled. And so therefore, n would have to equal 5. That's the proof of why that works. But if you can just remember that if the bases are the same, the answer is already there. It will go a lot faster. Whew. Okay. So, this assignment is too big. We're going to chop off some. And we will do a lot of review tomorrow to kind of make this all make more sense to you. So, I got to see. We're going to skip 3, D as in donkey, and 4, D, E, and F. Make sure there's no more down there further. Okay, good. Yay. Can you read me the next one then that we haven't done? Which one?
You want me to-
Which one did we just finish there? We just finished 2D. Could you read me the next one after 2D?
Yeah.
What is it?
Log base
What is it? 2E or?
2e. Yeah.
Okay, 2E. Read it to me.
Log base 2 of 72 minus log base 2 of 9.
When I told you that if you could ever combine these, you should, then you should, right? So we should put them together as one log base 2 of 9 times 72. And that seems like a trap because there's just going to be this huge answer. But here's the thing. I betcha that turns into 2 to a power. Whatever 9 times 72 is. I'm going to go off to the side and do 72 times 9. I bet you anything, 640, did anybody else get 648? Anybody else do 72 times 9? Oh, wait, is it minus? It's minus. It's minus. It's not 9 times 72. Oh my gosh. It's divide. You are correct. And it goes in the order that the problem was, which is 72 first. So it's 72 divided by 9. And that's 8, and that is 2 to a power. I suspected it was going to come out to 2 to a power. So that's really log base 2. I combined them, and when it's subtract, you divide them. Whew. Okay, it hasn't been this difficult in here in a long time. And 72 divided by 9 is 8. And then that one simplifies to log base 2 of 2 to the third. Bases are the same. Answer's already there. The answer must be 3. All right. So, I'm going to review all these properties with you tomorrow. And tomorrow is going to be basically a giant review day of today, except we'll add on just one little thing. So today was super intense, I know. Your assignment is now given, and I've even told you which ones to skip. Hardest assignment we've had in a while, but thanks for sticking with me. And by the end of tomorrow's review, I feel like you're going to be understanding logs pretty well. If you really get them as a switch back and forth, this is what we're going to keep coming back to, is that is the same as log base 5 of 8 equals x. If you can go back and forth like this way and that way, between exponentials and logs, that's the main thing you really have to get about logs. I've taught them all the way as high as the honors pre-calc level of logs, and it always comes back to this in some form or another. It's exponentials turning into logs and vice versa.